Morning, Nicole. Nicole, can you hear me?
Yes, now I can.
Okay, great. Good morning, Dr. Fogarty.
Good morning. How are you doing, Courtney?
Good. How are you? I guess I should turn my camera on.
It's nice to meet you via
You
Zoom.
too.
I like your picture. That's nice.
Thank you.
We just collected some D-Lab from off of Fort Lauderdale, so
Oh, awesome.
we're excited to spawn them next spring, early summer.
Ooh. Yeah, keep them cool.
Yeah.
Hi, Nikki.
Hey, Marilyn, how are you doing? Good to see you.
Good. How's it going?
Good.
Good to see you. Can we turn her up a little bit?
That's as high as it goes. I don't know.
I don't like it.
I can speak louder if you can't hear me very well.
Oh, here. I think that should be
Can
better.
you try talking again?
Yeah. Good morning,
Okay.
everyone.
All right.
Now I'm
Yeah.
blowing you away.
Perfect.
Turned it all the way up. Perfect. Well, we got a small crowd.
Yeah.
Are there more people? Oh, there's more people online. Okay.
Yeah.
All right. Well, let's give it like one more minute and then we'll get started. I see.
Sounds good. Thanks. Hey, Courtney, I want to introduce you to my PhD student really quickly. This is Krista LaForest. So she did her master's work with Joanna Figueiredo at NSU, and she is, so she has a background, she was looking at spawning asynchrony, and so she's interested in your project. So I invited her to join us. I hope that's okay.
Awesome. Yeah, that's great. Nice to meet you.
And great to meet you, and also hi, Rachel.
Yeah, I saw Rachel in the background. Hi, Rachel. Good morning.
Good morning.
A little family reunion.
There you go.
How was your trip to Florida? Did you guys get D-Labs?
We did, yeah. We ended up getting, well, Gilliam Lab collected some for us, and so I think we got, what, 7, and they had 5, and then we had one from the Keys that was shipped to us, so we have 13, and they look happy and healthy, so it was good. It was fun. Well, it's great to be underwater again, for one, and then it was just like a treasure hunt. We just swam and swam and swam until we found a D-Lab and collected it, and swam, so it wasn't like having your head down collecting data like it normally is. So it was a fun trip, a whirlwind, but a fun trip.
Were you guys checking for spawning at all? Do you know if they, no, okay.
No, we were just, the permit took a long time to obtain, so we missed this year's spawning. So we just wanted to get them into our system, be it, under our artificial lights and so forth for a year, and then we'll focus next April, May, June.
Okay, well, I think we will get started here. All right, so thank you to those in the room and those online. Welcome to Courtney's master's thesis proposal defense. So the way these typically work are Courtney's going to give the public defense part or public presentation part. We'll open it up for questions from the audience online and in the room. And then we're going to close it down for the committee meeting afterwards. And I just want to thank Rachel and Dr. Nicole Fogarty for serving on Courtney's committee. And if you don't know who I am, I'm Marilyn Brandt. So, okay, sorry, I usually say that first. But I wanted to just say that, so Courtney joins us. She got her bachelor's of science in marine biology from Eckerd College in 2019, and joined the master's program this past fall, but I had heard of her before that because she became the coral disease response and restoration coordinator for the territory back in 2022. So she was kind of thrown into the fire in a way. That was a very, she's working for the Department of Planning and Natural Resources, and a constantly changing situation. And since she's been here, she's helped to orchestrate a whole bunch of different responses to different outbreaks of things like the urchin disease, continuing to coordinate the stony coral tissue loss disease response, and then helping to take us through to the development of our coral restoration plan. So she works full-time for DPNR while also pursuing her master's project. So I've always been extremely impressed with her time management qualities. So she's going to be focusing on looking at coral spawning post the mass bleaching event of last year. And I'm really excited about her project, and I will let her take it away.
Thank you. So I'm going to minimize you guys. So Dr. Fogarty, I'll ask you if anything goes horribly wrong to unmute yourself and let me know. Thanks. Okay, so I'm going to be talking about post-bleaching coral spawning. Thank you, Dr. Brandt, for the introduction. And we're going to start at the very beginning. So what is a coral? A plant, an animal, a rock? So it actually has components of all three. So we see that this coral polyp pictured here has a mouth surrounded by tentacles that can catch floating food particles, bring it into the mouth, the gastrovascular cavity like a stomach. That's the animal part. They secrete a calcium carbonate skeleton, kind of like rocks. And then inside their living tissue, they also have an endosymbiotic microalgae, also known as zooxanthellae, that can conduct photosynthesis. So thousands of these tiny coral polyps are clones of each other and act together as one organism. And this endosymbiotic algae that lives inside them has a symbiotic relationship with the corals because the algae gets a home inside the coral tissue, and the corals actually are able to get energy from the photosynthesis that the algae undergoes. So although these corals can grab floating food particles from the water, up to 90% of a coral's energy can come from that photosynthesis, creating this symbiotic relationship. So without this endosymbiosis, a coral could eventually starve. So how do corals reproduce? They can reproduce asexually, meaning that there's no exchange of genetic information, through budding, where a single polyp is formed from the division of an existing polyp or from the space in between polyps, or through fragmentation, where a piece of the parent colony drops off and refuses to a substrate, and then becomes a new colony, but it's a clone of the original parent. There's also sexual reproduction, where there is an exchange of genetic information. One way this is accomplished is through brooding, where a male coral colony releases sperm, and that is ingested by the female coral colony. And then there's fertilization that happens internally within the polyp. And then the female coral colony releases this ready-to-go larvae for settlement and creates a new coral that is a combination of the DNA from both parents. There is also broadcast spawning that falls under sexual reproduction, and this can happen from gonochoric species where there is one male and one female colony, just as with the brooding. But in this case, both colonies are undergo a synchronized spawning, so they release their eggs or sperm at the same time, based around a lot of environmental factors like nights after the full moon, minutes after sunset. And these gametes combine for fertilization that happens externally in the water column, and then the coral also eventually settles. Then we have hermaphroditic spawning, where coral colonies are actually both male and female. So they will release a bundle of gametes that contain egg and sperm into the water column in this same synchronized spawning that separate. And then they'll combine with other coral colonies that have done the same thing in the water column for other external fertilization and eventually settlement. And then so this project is going to focus on these hermaphroditic broadcast spawners. So if we put it all together, corals release sperm and eggs in some way. The egg's fertilized, it develops, it seeks out a good substrate for settlement, larvae forms with mouth and tentacles, and then you have the new colony. And in sexual reproduction, this is, again, a combination of both parents' DNA. So there are benefits to this. Although corals are able to reproduce asexually, this diversification of genes is really important for the diversification of coral populations, as well as the distribution of coral populations. With genetic diversity, you get an increased resistance and resilience to disturbances and stressors. And sexual reproduction also happens on a far larger scale than asexual reproduction, where a single polyp can contain up to 100 eggs. In addition, because sexual reproduction happens in the water column instead of asexual reproduction, where you're just growing a single colony or it breaks off and forms a colony right next to the parent, in sexual reproduction, these fertilized eggs are going through the water column and are going to travel at far greater distances, bringing us back to higher diversification of reefs on a greater scale. So why are coral reefs even important? The corals and the reefs that they form are culturally, socially, ecologically important, economically important. Besides contributing to social norms and identity, these coral reefs are also impacting nearly 25% of all marine species, and they provide coastline protection, as well as providing about 500 million people with food and livelihood. But unfortunately, they also face a multitude of stressors, including pollution, sedimentation, overfishing, physical disturbance, and what I'm going to focus on today, which is heat stress. So when water temperatures increase too much or too quickly, or stay high for too long, the corals become stressed and they can expel this important algae that I was talking about. And this phenomenon is known as coral bleaching. And this is an issue because that algae, like we said, provides a ton of the energy for the coral. So when these corals are bleached, they're in a weakened state. So they're more susceptible to disease, predation, and any disturbance. And if this state continues, then they can ultimately lead to partial colony mortality or total colony mortality. And if this happens on a large scale, that is called mass coral bleaching. So the severity of this heat stress is traditionally measured in degree heating weeks. So up to for about 12 weeks, you accumulate how many degrees in degrees Celsius the temperature for that area has passed the predetermined bleaching threshold for sea surface temperatures in that area for that duration, which is about 3 months. And so if an area experiences up to 4-degree heating weeks, you hit a bleaching warning. Up to 8-degree heating weeks, you are likely to see widespread coral mortality. So I'm going to go through a few of the mass coral bleaching events that happened in the USVI that were over 8-degree heating weeks. And we can see that this mass coral bleaching is becoming more frequent and more intense, and the Caribbean is one of the most vulnerable regions. So here we can see the months on the x-axis by the first letter. On the y-axis, we have sea surface temperature with this squiggly blue line across the top. And then on the right y-axis, we have degree heating weeks that I was talking about before, with markers horizontally in red dotted lines for 4- and 8-degree heating weeks, where you would see coral bleaching and mass mortality. And then at the very top is a solid light blue line for the USVI's bleaching threshold for sea surface temperature. So this is for the 2005 bleaching event, and you can see it far surpassed 8-degree heating weeks up to over 15-degree heating weeks. So you can expect that we saw mass coral mortality there, and we did. We see this again past 8-degree heating weeks in 2010, again in 2019, and most recently in the summer of 2023, so this past October. And this was an unprecedented coral bleaching event that went up to over 18-degree heating weeks. So that's not good. And they barely have had a time to recover. You can see we're here in June 2024. That little orange peak is where we are now, and we're already starting another bleaching warning. So this study is going to focus on the corals that were monitored during this 2023 bleaching event. So because of these bleaching events and a multitude of other stressors, we're seeing a severe coral cover decline in the USVI. This graph is from Aaron Hollander's thesis analyzing territorial coral reef monitoring program data. You can see the years on the x-axis and percent coral cover on the y. And so there's been a huge loss just in the last decade. And she also noted that individual sites are losing up to 2% of coral cover annually. So what does that mean for spawning? Besides possible colony mortality, it can also disrupt natural cycles of the colonies that do survive. So this can impact their sexual reproduction on both visually bleached and visually unbleached coral. So even if it doesn't look like they bleached, if they were in that heat stress, they still may be affected. And we saw in the Florida Keys, spawning was negatively impacted following the years of bleaching. And then in the Virgin Islands, we don't know directly how bleaching impacts our sexual reproduction of coral colonies. But some unpublished data from Brad Arrington on a study that he conducted shows here the years on the x-axis, coral recruits on the y on the left, and then degree heating weeks on the right. We see that red line is maximum degree heating weeks. So they went up to not even 8-degree heating weeks and saw very low coral recruitment that year and the year following. So it's likely that this 2023 bleaching event that just happened is going to impact the sexual reproduction and coral recruits in the USVI in the next coming years. Why is that? Because healthy adults mean healthy larvae. So if an adult is stressed, it can actually reabsorb those eggs that it was creating to maintain that energy that it's losing because it's not having the photosynthesis of that algae that it released from coral bleaching. So up to 85% of an egg can be lipid content. So that's a lot of really nice fatty energy for the corals that would usually be used for an egg or a larvae while it's searching for a suitable environment to settle on. So we've seen that the lipid reserves of adult Orbicella fabulata corals have been depleting or have been shown to deplete during bleaching events, and they can take up to a year to recover or longer if they ever return to those pre-bleaching levels. And this depletion of lipid content in adults during and following bleaching events might impact the ability for these adults to produce these eggs that contain so much lipids. So these corals that have undergone this thermal stress might not have enough energy stores to produce gametes. So to analyze the coral sexual reproduction in the USVI post-bleaching, I'm going to be focusing on 3 hermaphroditic broadcast spawning Caribbean reef-building species, one being Diploria labyrinthiformes, Orbicella fabulata, and Acropora palmata, with the last 2 being under the Endangered Species Act. So Diploria labyrinthiformes, the common name of grooved brain coral or D-lab, they uniquely spawn in the spring and uniquely typically in daylight. And they exhibit a lot of qualities of brooding spawners, like short larval phases and high settlement rates. Orbicella fabulata, or the mountainous star corals, or OFABs, are massive bouldering species that typically spawn in late summer and early fall, and they're associated with low colony mortality during bleaching events, possibly due to their high biomass, but they could be more susceptible to disease after bleaching events. And then Acropora palmata, or the elkhorn coral, or APAL, gets its name from its shape. They tend to live in shallow waters with high wave energy and are associated with high mortality during these bleaching events. And both Orbicella fabulata and Acropora palmata have seen severe population declines since the 90s. So my project is going to aim to uncover ecological interactions between coral spawning and bleaching events through a few different ways, and I'll go through each of them individually. So first, by determining if coral colonies that exhibited bleaching during the 2023 mass bleaching event spawn in lower frequencies than corals that did not exhibit visual bleaching during the same event. So these corals are going to come from St. Thomas, USVI, which is the most densely populated of the 3 major US Virgin Islands, noted by the star in the top figure. And we are going to be looking for D-labs in Brewers Bay in the bottom figure, denoted by the orange oval, which is located on the southwestern edge of the island, bordered by the only airport on the island, a popular beach, and the University of the Virgin Islands campus. So because it is so close to the university, it's really easy access for students. And actually a previous master's student conducted another study coring and photo monitoring some of the last remaining Diploria labyrinthiformes on that patch reef starting in 2022 and throughout 2023. So those are going to be used in this study. Our Orbicella fabulata are going to be located in St. John, denoted by the star. St. John is the smallest of the 3 major US Virgin Islands, and it has 60% of its area protected by the National Park Service, so there is little development comparatively to St. Thomas. And the 2 reefs that are chosen as study sites have been historically monitored by the University of the Virgin Islands National Park Service Stony Coral Tissue Loss Disease Treatment Team. And they've photo monitored through that 2023 bleaching event. The first, the northern orange oval, which is Wind Spirit Reef. That's exposed to the northern swell. It's the furthest of the sites from shore, and it's sloping from about 10 to 25 meters. It's a patch reef with less rugosity and less coral cover than our other sites, but there have been Orbicellas found there. And then Turner Point, the southern orange oval, is a spur and groove reef. It's the most protected site from wind and swell. It's just offshore, but has about the same depth as Wind Spirit. And then for Acropora palmata, we're back in St. Thomas. And we're going to be using observations that were collected by the Acropora Monitoring Program, which is administered by the University of the Virgin Islands, which documents variability in bleaching and Acropora health throughout the territory, including through this 2023 bleaching event. So possible locations for this species will be Thatch Key, the northern orange oval, as well as Cow and Calf Reef, the southern orange oval that is actually in the St. Thomas East End reserves. So all of these corals that are going to be chosen have been photo monitored through the 2023 bleaching event, and they will be analyzed. I'll analyze those photos and place the corals into either a bleached category or an unbleached category based on what happened to that species during the event. And all of these colonies will be over 20 centimeters in size because that is approximate spawning size. So for our Diplora labyrinthiformes, if they were over 80% bleached, that puts them in the bleached category. Under 5% combination of bleached and paling would be an apparently healthy colony. For Orbicella fabullatas, if they were over 90% bleached and paling together, that counts as bleached. Under 10% bleached and paling combined would be apparently healthy. And then for Acropora palmata, over 50% bleached and paling puts them in the bleach category, with less than 5% bleached and paling combined puts them in the healthy category. And these are all just different based on the species and how they kind of separated themselves during the bleaching event. The Acropora was difficult to find species that had severe bleaching that survived, which makes our bleached and unbleached categories a little closer than the other species. So we are going to take 10 D-labs, Diplora labyrinthiformis species, into water tables at UVI. We have found 6 bleached and 4 unbleached. For Orbicella fabullata, we're going to take those in as well to water tables at the UVI. We found 23 of those, with 14 being bleached and 9 being unbleached. And then the Acropora palmata are going to stay in situ, and we're going to be monitoring 5 bleached and 5 unbleached colonies. So we'll monitor spawning for all of these in order to determine that objective if coral colonies that exhibited bleaching spawn in lower frequencies than coral colonies that did not. And we'll be using t-tests to determine if there are significant differences between those bleached and unbleached groups for each species. And I expect that the species that did not visually bleach are going to spawn in higher frequencies. So part 2, determining if previously bleached or unbleached corals produce spawn with higher lipid content. So we're going to be using that spawn that we monitored from part 1 in cross-fertilization experiments. There'll be 3 treatments as noted by the top figure, and those would be a larvae that has parents, 2 bleached parents, 2 unbleached parents, or 1 from each group. And then that will result in Diplora labyrinthiformes having 24 individual crosses of a bleached and unbleached parent, as well as a batch cross of bleached parents and a batched cross of unbleached parents. And it's the same setup for Orbicella fabullata, but because of the higher numbers, it would result in 126 individual crosses. And then the Acropora palmata won't be collecting spawn since they're in situ. So we'll get samples of those spawn from each colony that produces, and they'll be frozen in salt water at -80 degrees Celsius and shipped to Dr. Justin Kemp at the University of Alabama for analysis. So to determine if these previously bleached or unbleached corals produce higher lipid content, there'll be t-tests conducted for each of the treatments, and we expect that the corals which did not visually bleach will produce spawn with higher lipid content, so that spawn that has 2 unbleached parents. Part 3 would be analyzing the differences in larvae settlement, growth, and survival from parent crosses between those same 3 treatments. And to do that, we will rear those larvae to settlement that we collected. The larvae will be observed throughout that process, and their development will be tracked using a dissecting microscope and image capture, kind of like in the top image, throughout their different phases. And then they will be settled onto ceramic settlement tiles that have been preconditioned in the same seawater flow-through system that their parents are in. And then they'll also be sprinkled with coralline crustose algae dust to encourage settlement. And as they settle, we're going to be recording the time to settlement, the percent of larvae settled, the percent of survivorship in the larvae that settled over time weekly, the onset of symbiosis, and then the onset of tentacle development. And that will happen for 12 weeks or until all have hit tentacle development. And then we will start recording monthly until the larvae reach appropriate outplanting size of 1 centimeter, and we'll put them back out on the reef. So to analyze the differences between these treatments for these variables, we'll be using a linear discriminant analysis, or LDA, to simultaneously highlight the similarities and differences of all the variables across the different treatments. And we would expect that the larvae with 2 parent colonies that did not visually bleach are going to have higher settlement rates and survivorship than the other treatments. And last but not least, to try to identify an accurate spawning window for our 3 study species. So for our D-labs and our OFABs, we'll use our ex situ observations of spawning in those water tables. And then for Acropora palmatas, we're actually going to be doing in situ remote camera monitoring. So we're going to be using custom-built cameras with custom-built circuit boards that are 3D printed carriages with Blue Robotics underwater housing and light systems that are going to be positioned onto the reef by divers prior to the Acropora spawning window. And then we'll set these cameras to take photos at 1-minute intervals during the Acropora spawning window from 0 to 12 days after the full moon. And during their spawning time window in minutes after sunset, resulting in 180 photos per colony per night. And so in order to identify this accurate spawning window, we'll be analyzing those images and recording the date that the spawning occurred, time of setting if possible, and beginning and end time of spawning. And then, of course, the same data for our ex situ species, D-labs and OFABs. And we just expect to get an accurate peak spawning window for each species here in the USVI. So you may have noticed that all of this depends on coral spawning. And in the beginning, I told you that if there is bleaching, it's likely there will be no coral spawning. So if they don't spawn, I will be using histology, which is the study of the anatomy of tissues using stains to sample all of these corals and hopefully more to look at their stage of gamete production. So we'll process these samples and determine their stage of development to see if they're even close to spawning or not, and then analyze the difference between those colonies that we know bleached and didn't bleach, and get a general idea of where the USVI populations are at. So why is this important to do? Well, sexual reproduction in the wild, their benefits also apply to restoration practices on land. So due to the increasing need for large-scale restoration of corals, practitioners are turning to sexual reproduction to try and meet those quantitative needs that are also genetically diverse. And this sexual reproduction also allows for restoration practitioners to select corals with the best genes that are most likely to be well adapted to fit our changing environments and handle these stressors that are being put on them. Because it has been shown that corals can pass down mutations that they have acquired during their lifetime to their offspring. So if this in situ gamete collection isn't possible because of continued bleaching events, it's really important for coral practitioners to know that they're going to have to bring in broodstock or parent colonies of these corals multiple years before they want spawn, keeping them at in unstressful environments if they want to get healthy and reliable spawn that are going to create more corals. So this project will document the capacity for sexual reproduction currently to help with different territorial management decisions like restoration, rescue, pictured here, and bleaching management decisions in general. And then the spawning window aspect is really important because of our changing conditions, and that spawn can be or is determined by different environmental factors. The fact that we are having so much heat at different times of the year than corals are used to, it means that there is a possibility for their spawning window for these corals to change. So that's something that we're going to need to find out. So the timeline for this project is throughout May 2025, so a little less than a year from now, and it's funded by a Department of the Interior Coral Reef and Natural Resources grant through the Department of Planning and Natural Resources. And this is my works cited, and I'd like to thank Dr. Marilyn Brandt, my advisor, Dr. Nicole Fogarty, and Rachel Ainata for helping me put all this together. Thanks. Sure. Well, we can take any online questions if you guys have them. Doesn't look like it. Any questions? Yeah, Liam.
How long does it take for corals to recover after?
So the question was, how long does it take corals to recover after bleaching? I think that's something that's still being studied, and it also depends on like what you mean by recover. So like we were saying, the lipid content isn't going to pre-bleaching levels for multiple years afterwards. But if you're just talking about regaining their like color back or their symbionts, I think it's variable for different species and depending on how and the timeline of the decline of heat stress. So it's like if it just drops off, it might be different than if it slowly goes back to normal temperatures. So yeah, I think that there's no like one answer to that. It's yeah, super dependent on so many factors and yeah, variables. Any other questions? Yeah. The cameras. So the question was, how are the cameras being secured underwater? So we're going to zip tie them to cement blocks, and hopefully that will just be heavy enough to position them in the right spot, leave them there for 2 weeks, and then we'll go and collect them, cut them off the zip ties, and take out the SIM card. Yeah.
I think we talked about it the other day, but exactly what type of lighting?
Yes. So the question was, what type of lighting are we using? So this is something that I'm interested in as well. So we're using just a normal white light. It's a Lumen Blue Robotics light, if that means anything to anyone. But it's just normal white light that's going to be flashed at 1-minute intervals over their whole spawning window. And so there's some controversy maybe in the field if white light really is going to affect coral spawning because they're influenced by the moon. They don't spawn in the daylight, and how sensitive they are to that. I will say that last year, the Nature Conservancy in St. Croix used these same cameras, and they were able to capture Acroporas spawning with the same lights. But yeah, I am not sure how that white light being flashed at them for over an hour is going to affect their spawning rates. Yeah.
Why aren't you bringing your camera into the
Acropora, I think historically do not do well in water tables. They're also massive colonies, so I don't think they would fit in the water tables. They'd be really cumbersome to move. They're also a highly endangered species, and there's not a lot of them left, and they get really stressed out really easily. So I don't think that there would be any success in bringing them in. I don't know if there's many coral practitioners anywhere that have Acropora in water tables because of all those factors. Unless, correct me if I'm wrong.
Well, we did Palmati.
Yeah, water
Yeah.
tables.
Oh,
with their little-
Yeah, tiny
Yeah,
fragments.
big palm.
Yeah. And if we were to frag them and bring them in, that might affect their spawning as well.
They really do.
Are you doing the video recording of those as well?
Yeah, so the Acroporas will just be video recording. They'll be the only ones video recorded since they're staying out there.
If they redundancy with your cameras in case they fail in the water.
Nope. No, so we have 10 cameras that were brought down by a collaborator. Oh yeah, we have 8 right now. We're getting 2 more. I set them up yesterday, and the person who made them, because they're custom built, told us that it's really difficult to remove the batteries once you put them in, and you might have to crack the housing. I don't even know if you knew this. You might have to crack the housing to get the batteries out, so you'd need new housing if you wanted to do it again. So it's kind of like a one-shot.
It's like the black insert. It's not good.
Yeah.
Yeah.
But we can still charge them while they're inside the housing. So theoretically, we could put them out and let them die and recharge them and do it again. But yeah, there's only like one set of cameras. It looks like we have a question online from Krista.
Yeah, great job, Courtney. I was wondering, so when I know you say you're doing the D-Lab and OFOBs as XC2, when are you bringing those corals in to do observations, and how long are they planning on staying in your systems?
So great question. We are bringing them in immediately prior to their spawning windows. So we already did D-Lab, but maybe like a week or 2 weeks before they're supposed to spawn so that they can acclimate to the tanks a little bit. And then we'll just put them back out on the reef after the spawning window because we don't really need them anymore after that.
Great. And then I had another question. So there's at least a paper for Fabulata that it can take, up to 2 years for fecundity levels to return back to normal after a bleaching event. Do you have any data on these corals? So you have last year's bleaching. Do you have anything from the year prior on them about whether they bleached or not?
No, yeah, we only have this current monitoring. I think like monitoring efforts for bleaching like on a coral colony level have really just started now that bleaching is like ramping up and becoming this continuous event that's happening instead of one-time events that might not happen for a while. Yeah.
Thank you.
Yeah.
Courtney,
But it
a
would be
follow-up
cool. Oh,
question.
yeah.
A question about what Krista was talking about as far as bringing the corals in. The the lab has changed a lot since I had been there last with the hurricane. So walk me through just any potential light pollution, the lights, everything's turned off. Also, are they still detecting moonlight? It looks like from your photograph, there is a cover over them. Kind of walk me through some of the precautions you're taking for both light pollution and making sure that they're getting the natural cues.
Yeah, so the tables, the water tables do have that shaded structure on top. It's not full shade, it's like kind of opaque, clear plexiglass. I don't know if that's the right word for it. But that is to protect it from like the direct sunlight during the day. And then at night, what? And water inundation, yeah, in case it rains. And then at night, there is one bright overhead light that is on all the time. But it's not directly overhead. And there's also a light shade across the top of all the water tables. So yeah, we don't really know how that is affecting them, but in the same lab 2 years ago, we did see spawning from D-Labs and Orbicella fabulata. So in theory, last year?
Last year, about 2 weeks. Yeah.
Okay, so last year and the year before, different species still spawned in those same tables. So, right, but the corals that did spawn had been acclimating and not under stress in the tables for over a year. But theoretically, they're still getting those natural cues in order to spawn.
Gonna be a weekly thing.
Yeah, and yeah, things might move during the duration of this project. So, yeah.
Okay, we'll talk more in the closed session,
Okay.
some things that maybe you can do to help that.
Yeah. Okay. Yeah, Abby.
These corals all have like similar.
No, yeah, that's a great question. So the question was if the clades have, or if the corals have similar clades of symbionts. So we don't know, like we can't know unless we test each coral, right? So we actually did take symbiont samples of the coral colonies that we've been using for spawning to find that out. But there's been previous research done on symbionts, and it looks like there is some variability, but I think generally one species has similar symbionts throughout the territory if they're in the same location. And so like all of our corals are going to be coming from a single reef for each species. So they should be pretty similar, but we will find out. Dusty from University of Alabama is going to be doing the symbiont analysis for those. Yeah. Any other questions? Okay. Yeah.
Gonna move to the bonus portion. Vicky, can you stay online and then we'll just give it a couple minutes.
Sure, no problem.
Take out.
And yeah, thank you everyone else for coming.
The junior.
I don't know. Thank you. Thank you.
Stop, Courtney.
Thank
See you later.
you. Bye. Thanks, Addie.
You know where?
Thanks, Nicole. Am I still recording? How do I stop?
On Teams. You can never stop. Try pressing that button. Oh yeah.
Stop.